Hello again. So let's continue with the GitHub docs. We'll read the next article about workflows from Right Workflows topic, and I unfortunately clicked go home. Okay. Anyways, let me switch my view so you can see more of my browser rather than me, and let's go through the documentation. Okay, about the workflows. A workflow is a configurable automated process that will run one or more jobs. Workflows are defined by a YAML file checked to your repository and will run when triggered by an event in your repository, or they can be triggered manually or at the defined schedule. Okay, we already know that. Workflows are defined in GitHub Workflows directory in a repository. A repository can have multiple workflows, each of which can perform a different set of tasks, such as building and testing pull requests, deploying your application every time a release is created, adding a label whenever a new issue is opened. So we should already know that from the previous articles. So workflow basics. Again, we have our event which triggers the workflow. We have two jobs. Each job has a separate runner and it has a step, so I think I won't read out loud this part of the documentation. We are already familiar with the definition of a workflow. Triggering a workflow. Workflow triggers are events that cause a workflow to run. Okay, these events can be events that occur in your workflow repository, events that occur outside of GitHub and trigger a repository dispatch event on GitHub. Okay, scheduled times and a manual. So for example, you can configure a workflow to run when a push is made to the default branch of your repository, when a release is created, or when an issue is opened. So we have seen in the previous video how we created a workflow on push events. We actually just copied it from the documentation. Workflow syntax. Workflows are defined using YAML. For the full reference of the YAML syntax for authoring, see the documentation here. For more on managing workflow runs, such as rerunning, cancelling, or deleting a workflow, see managing workflows and deployments. Okay, we probably see that in the later videos. So let's continue with this documentation. GitHub provides pre-configured workflow templates that you can use as is or customize to create your own workflows. GitHub analyzes your code and shows you workflow templates that might be useful for your repository. For example, if your repository contains Node.js code, you will see suggestions for Node.js projects. Okay, these workflow templates are designed to help you get up and running quickly, offering a range of configurations such as CI, deployments, automation, code scanning, and pages. And yeah, so there's a full repository of basic workflows that we can use. Use these workflows as a starting place to build your custom workflow, or use them as is. You can browse the full list of workflow templates over here. And for more information, see the using workflow templates. Okay. Advanced. Okay, let's hide this pop-up. Advanced workflow features. This section briefly describes some of the advanced features of GitHub Actions that help you create more complex workflow. Storing secrets. If your workflow uses sensitive data such as password or certificate, you can save these in GitHub as secret and then use them in your workflow as environment variables. This means that you will be able to create and share workflows without having to embed sensitive value directly in the workflow YAML source. This example demonstrates how to reference an existing secret as an environment variable and set it as a parameter to an example command. So what we have here, we have a definition of job. The name is example job, which runs on Ubuntu latest, and have a step retrieve a secret. Here we define environment variables, and we have a super secret environment variables in this step. So the scope is only for this step, and here we just reference it as super secret from secrets. And we run example command to display our environment variable. So yeah, let me maybe copy this and use the repository I had previously. So this is our previous workflow. Let me paste it over here, and we have to have a super secret configured in our repository secrets. So let's do that before pushing code to the repository. Do I have? No, I don't have GitHub open. I hope I'll be logged in. Yeah, good for me. Okay, I'll have my repo. I'll go to settings. In settings I can use secrets and variables and actions, and here I can repository secret. I can add a new repository secret. So let's paste the name of the secret same as in our GitHub action, in our workflow actually. Okay, this will be our secret, and yeah, that way we have one secret which we can edit, but we cannot preview it over here. So let's go back to actions. We have our GitHub action demo, so let me just let me save the change. Let me commit, stage the changes and git committed. Before I push, I need to add my SSH key. Let me do it off screen, because I don't usually have it auto added. So yeah, great. Okay, so let's now git push our changes to our repo. Let me check. Okay, yeah, I remember I made changes inside the repository. Okay, so let's see. Let's just try to pull the changes before we do. Can I do it like this? Okay, it will not allow me to do it. I don't want to start playing with git commands. Where to can also part rebase or no rebase? Let me just try this command, git pull fast forward only. Let me see. Not possible to. Okay. I'll just paste the changes directly in the repository. And I will deal with the merge conflict later. So let's do a commit over here. Commit changes. Right, let's go to GitHub Actions. So as we can see again, we couldn't make changes, and those will be pushed directly from our GitHub repo. And let's see, example job, and it failed. Oh, that's something interesting. Example command not found. Which command? Yeah, example command. That's right. There is no such thing as example command in Git. So let's make the changes to our sample YAML file again. Echo. Let's echo the secret and see if it will be shown in the GitHub Actions. That's what you get when you don't read what you're doing. Okay, sample job. I have a green tick mark, retrieve secret. Oh, and it's not shown here. Huh, that's interesting. I was expecting to actually see the secret here, but I see GitHub is clever and not shows the secret, although I want to echo it as a variable. Okay, but yeah, we tried and I failed. Probably there's a different way to do it, but I won't be spending my time now at it. Let's continue with the documentation. But it's good to know that the GitHub by default doesn't allow you to display your secrets in logs. It's quite good a practice to not display it anywhere. Okay, created dependent jobs. By default, the jobs in your workflow all run in parallel at the same time. If you need a job that must only run after another job has completed, you can use the needs keyword to create this dependency. If one of the jobs fails, all dependent jobs are skipped. However, if you need the jobs to continue, you can define this using the if conditional statement. In this example, setup build test job run in series, with build and test being dependent on successful completion of the jobs that precedes them. Okay, so let's again copy this, go to our GitHub repo. Let me just try Let me just try again git pull with rebase. I want because I don't need to have the history in this repo, as it's only a repository that I do for testing GitHub Actions. Okay, so if I do rebase, I'll overwrite the history, local history. So let's go to our conflict editor. Let's hide our. Let's do accept current, complete merge. Great. Continue. So I've merged with the rebase. Let's run this one, and we have what we have. We have again job with the name setup that runs on Ubuntu latest, and the step for it is run a script. I don't have this script, so it will display me an error. So let's just echo step 1, and the build job needs a setup, and let's again echo step build, and the test needs the build, so it will be connected in a dependency. Well, let me write this. Okay, let me stage the changes, commit them. Let's test dependent jobs. Should it end with T? Let's write it like here, and let's push it to our Git repository. Yeah, now I can push, as I have the same history as in GitHub repo. I don't actually care about it, as it's only for testing purposes. Okay, we have our action, and now we can see our graph of dependencies. we have our setup step, we have build step which needs a setup to run, and we have our test step that needs our build to run. That's why it's connected in this single line graph. So instead of running in parallel, we have each of our graphs running one after another, because one is dependent on the other. And we have our step 1. In our build step we have step build, and in our test step, as we have defined in our YAML file, we have step test. Okay, great. This at least work from the start. Using a matrix. A matrix strategy lets you use variables in a single job definition to automatically create multiple jobs run that are based on the combinations of the variables. For example, you can use matrix strategy to test your code in multiple versions of a language or on multiple operating systems. The matrix is creating using strategy keywords. Strategy keyword, which receives the build options as an array. For example, the matrix will run the job multiple times using different versions of Node. Okay. So again, let's just copy and paste what we have here. Okay. So we have our job build, which uses strategy matrix and has node 14 and 16. And in step, we set up node. We have GitHub Actions set up node v4. And we're gonna use our matrix, not environment variable or secret, but we're gonna use our matrix with our value of node. This way we should run probably in parallel 2 runners, which will run 2 jobs. Okay, let's test matrix strategy and let's push it. And again, on push, our action will be triggered. And we have 2 jobs. As you can see, it's in a matrix build. And we have build 14 and build 16. And if we go to the build 14, post-job cleanup. So attempting to download 14, and on the build 16 we should see that we were using node 16. Yeah, and with the matrix strategy we can actually define more. For example, OS, that will be Ubuntu or Windows, and this way we would with node version. Here we have node version, but we could also say that we would run echo matrix OS. And I have a problem. Expected value run. Should I use it like this? Unexpected run. Okay, so maybe in step I need to do it as such. Yeah, okay, I would have to do it like such, and this way we have the first step, which is using the Node.js setup action, and then we will be running our echo command. I wonder if it will work out of the box. Test again matrix. This way we let me stage the changes and push the change. This way we should see running 4 jobs, and of course we maybe let's see if it will run, if I didn't make a mistake. Yeah, we have 4 jobs, and as you can see the matrix allowed us to run build 14 on Ubuntu and on Windows, and 16 on Ubuntu and on Windows. We can add as many tests and combinations of variables as we want, and we can also exclude, I believe, node for, yeah, but I don't quite remember the syntax, but I believe if let's ask ChatGPT, that would be the easiest thing to do. Am I here? Yeah. How in YAML GitHub, maybe let's start a new chat. You don't need to read my history, where I was asking about the description for my videos. Write me a YAML file for GitHub workflow which uses matrix strategy and strategy for node version 14 and 16 and operating system Ubuntu and Windows. I want to exclude operating system Ubuntu from node 14. Let's see if you understand my command. So we have a name, we have push or pull requests. Okay, and we have here. So that's how should I exclude the node 14. You can always ask ChatGPT to write something you need, but you need to be quite specific about naming workflows, jobs, and everything with the correct name. Runs on Matrix OS. Okay. Yeah, but I didn't want the Matrix OS to be right here, but probably it could work. Yeah. Anyway, I was interested on how to write exclude, so I can copy probably this part to my code. Save it, commit it, and see if we were able to achieve the expected outcome. We got 4 jobs. Okay, my mistake. It's not Ubuntu latest. I wanted to exclude Ubuntu. Now this way we should have less jobs. And as we see, we have 3, not 4 jobs. So for node 14 we excluded the Ubuntu variable. Okay, let's try to finish the documentation today. If your job regularly reuses dependencies, you can consider caching these files to help improve performance. Once the cache is created, it's available to all workflows in the same repository. This example demonstrates how to cache the npm directory. I don't have a node project in my repo and don't want to create any directory currently. So let's just read how this job should work. So we have a job, which is our job with example job with steps. First we need to configure our action. We want to use actions cache. Then we have our environment variable, which is cache node name. We'll be using it with path.npm, and the key, we will provide a key, restore keys, so it will be the same as the starting of the key. Should it not end also with these hash files? Yeah, I believe the restore key should also have this ending. Yeah, but you can cache your directories or outputs of workflows using the action cache and use it in different workflows. So for example, if you have code which have been built previously, or you have maybe monorepo where you build different parts of your application, you can cache those if some of the if the files, let's say all the files, should not change, so you can cache the whole build and just reuse it, so you won't have to spend time and resources running your actions for building the files, just reading them from cache using databases and service containers. Okay, I have not known we can do it. If your job requires a database or cache service, you can use services keywords to create a ephemeral container to host the service. The resulting container is then available to all steps in that job and is removed when the job has completed. This example demonstrates how a job can use services to create a Postgres container and then use Node to connect to the service. Okay, let's check it out. So we have container job, we'll be run this on Ubuntu latest, and we have a container, so that's the name of a container, service Postgres, image Postgres. Checkout repository code, so we will use the action checkout to have access for the workflow to our repository. We will install dependencies if we have any code in our repository, and we're gonna run our Node.js script with environment variables. Yeah, so we will have to read those variables in the script, and it can test our connection to the container which is defined in the workflow. Well, that's quite useful if you want to check your connection to different databases, maybe Postgres, MySQL or something. If you think about inversion of control, where you just have maybe a database factory and you want to check your connection to different databases, so you can just create tests for connecting to MySQL, Postgres or any other DB. You just use your factory to provide you with some service to connect to each of the containers, each of the databases, and just run each script to check if your implementation of the database service is working. Yeah, seems like this could work. I should probably draw it. Maybe next time we'll just spend some time and try to draw it. Okay, but let's just end the documentation for today. If you want to be sure that the particular type of runner will process your job, you can use labels to control where jobs are executed. You can assign labels to a self-hosted runner in addition to their default label of self-hosted. Then you can refer to these labels in your YAML workflow, ensuring that the job is routed in a predictable way. GitHub hosted runners have predefined labels assigned. This example shows how a workflow can use labels to specify the required runner. runs on self-hosted Linux 65 or GPU. A workflow will only run on a runner that has all the labels in the run on array. The job will preferentially go to an idle self-hosted runner with the specified labels. If none are available and a GitHub hosted runner with the specific labels exists, the job will go to a GitHub hosted runner. Okay. Reusing workflows. You can call one workflow from within another workflow. This allows you to reuse workflows, avoiding duplication and making your workflows easier to maintain. For more information, see reusing workflows. Okay, that's cool. And quite self-explanatory. You can treat work, if you're a programmer, you can treat workflow as a function which you can invoke from any other function. So yeah, quite simple to understand. GitHub provides security features that you can use to increase the security of your workflows. You can use GitHub built-in features to ensure you are notified about vulnerabilities in the actions you consume, or to automate the process of keeping the actions in your workflows up to date. Okay. Using environments. You can configure environments with protection rules and secrets to control the execution of jobs in a workflow. Each job in a workflow can reference a single environment. Any protection rules configured for the environment must pass before a job referencing the environment is set to a runner. Okay. So yeah, that would be all for today. Just to make summary, we can define labels on which we would like to run our jobs, and if there will be a runner available with all those labels, it will be picked up by our workflow. We can define containers with some services, and we can test connections or any other implementations. So we can quite abstract our tests from underlying infrastructure, and we can test them against the containers and services provided in workflow. We can cache some of our work done before with GitHub Actions cache, and we can read it in different workflows. We have a strategy matrix which allows us to define different variables and run multiple workflows in parallel or in sequence. But yeah, matrix is rather used to run in parallel if we have a if we, for example, combine the matrix with some of the services, so we could run a connection to Postgres, MySQL or MariaDB SQL database and test our implementations using the matrix strategy instead of defining the steps. If most of them will be quite the same, we would just have to provide a different environment variables to one of a step, to probably just pick up the correct script or correct implementation of our database service in our container. We can depend our jobs one on another, so we can run tests only after we build our code, and we have secrets and environment variables which won't be so easily displayed to us. So yeah, that will be all for today. Hope you enjoy. I will see you in the next video where we will try to use workflow templates. So thank you again. Thank you for your time. See you there. Bye.